Hello, I hope it's going well. I have been ill. This is just a random video. I'm practicing maths and I thought it'd be just fun to do a video of it. So this is the question. It's a Fourier transform question. We're given all the information we need. So first of all, we find the magnitude and phase spectra and then we sketch the graphs. So the first thing that you would figure out is you will have basically an equation sheet that will state things, and this is the first thing that we need to remember or see in the equation sheet, which is the shifting theorem, I believe it's called, and it equals, this is what I'm writing, this is the shifting theorem, and as we can see, it makes sense given that there is going to be a magnitudes and phase spectra. As we can see, we've got the J, which is an I for mathematicians, but we use a J in engineering. So this is what we get. So this is the rule, and we're going to use the rule to figure out what this Fourier transform pair equals. So we have this G minus 3 squared. Obviously we can already see it, it's the UT, but we're gonna use the F, which gives us E minus 3 WJ, and then times, or the dot of E, let me see, minus 2, and then the magnitude of this. So we can see we get that last bit from here, and we're timesing it. Hopefully that's kind of seeable. So this bit gives us this, and then the rest of it, like I don't know how to show you, but equals that. So we times it, and we get the value of this. E minus 3 WJ. Okay, and we can actually see that this is already written in polar form. Polar form is J there. So the magnitude is R, which is the R here. And we can see from this that we have this whole thing here is R. So it's pi over 2 e negative to the power of negative 2 times the magnitude of W. And, well, I should spectrum here. And then we have the phase spectrum, which, as we can see, is this, and we see it here. So it is negative 3W. And now we have to draw the graph. So the phase spectrum is pretty simple. It's negative 3W. So, I mean, actually, I shouldn't have written negative, but we've done it now. And it goes through. Let me just make sure I get this right. So I'll say, let me just make this more clear. 2, negative 2. This is the draw the phase spectrum. And we just have this. And here it should be, sorry, I'm quite bad at drawing this. Because 2, it's just times by 3, so it should equal about 6. Not about 6, but 6. Cool. And then we need to do the magnitude. I'm going to do this one like this. This one's a lot more complicated. So this is, this is the magnitude we can see. And again, we have W because it's in terms of W. And easiest thing to do is to find out what it will equal when W equals 0. And we'll have 0, so I'll have 1, so it's pi over 2, which is about 1.6. Not exactly, obviously, but we'll just give that. And then, if we think about it, there is a magnitude, right? So that means that we have this kind of form. Sorry, it's really badly drawn, but there we go. So this is 0, and this is about 1.6. Cool. Or actually, I could just write pi over 2. Okay, that's the question done. It's not a very complicated one when you know how to do it, but I mean, the key here really is to be able to do Fourier transforms. And as soon as you get them, you keep on doing them, you see it immediately. And so something that might take 5 minutes if you don't really know them will literally take 10 seconds if you do know them. But that would give you 5 marks, which I think is pretty good given the work. But that should be that. And I hope it was useful. There we go.